Why are collisions so important? Well, otherwise these fences in Just Cause would just fall through the ground, or this boss in Hollow Knight would just bounce through a wall, and all enemies in Cuphead would not take any damage. Collisions are crucial to making a free-flowing and reactive game. So what is a collision? A collision occurs when the shape of an object overlaps with another object. When this happens, it is up to the programmer whether to do anything with this collision. They could invert their velocity, stick together, or just glow red. The role of a collision is just to detect if an object is overlapping, not to do anything with it. I will showcase two types of simple collision detectors, a circle collider and a box collider. Then I'll show how to make these in C++. The circle collider is one of the fastest collision detectors. You only need two variables from each circle, the position and the radius. Now these two circles are not colliding, but these two are. What's the difference? If you were to compare the sum of the two radiuses of the circles with the distance between them, you will notice the collision occurs when the distance is smaller than the sum of the two radiuses. We can put this into an equation, where we find the distance using Pythagoras and compare that to the sum of the radius, and that's it. The box collider is a little bit more complex, but still very fast. Instead of comparing the radius, it compares the corners. If a corner overlaps with another corner, a collision occurs. For the sake of simplicity, I'll only refer to the top left corner and the bottom right corner. Another thing to note is in OpenGL, the y-axis is inverted. So instead of increasing upward, it increases downward. With that in mind, let's take these two squares and compare the x coordinates. Let's call the left box A and the right box B. A collision only occurs when the top left corner of A is less than the bottom right corner of B. Similarly, the bottom right corner of A must be more than the top right corner of B. Let's do the same with the y coordinates. The top left corner of A must be smaller than the bottom right corner of B, and the bottom right corner of A must be more than the top left corner of B. Combining all these things together creates a criteria for box collision. So how would you write this in code? For this, I'll be using the entity class that we made in the previous video. Check that out if you haven't already. For the circle collider, we need two variables, position and radius. Position is already accessible in the entity class. For radius, we're going to need another method to find this out. First, let's get the height and width of the sprite. Then compare which one is the largest. The height and width is essentially the diameter, and the radius is simply half the diameter. So that's how we get the radius. Next, let's make a getDistance method. I'm going to make this an inline helper. This just gets two vector2 variables and uses Pythagoras to find the distance between them. With that done, we just need to compare the distance with the sum of the radiuses, then check if both entities are alive, and we're done. For the box collider, the hardest part is finding the bounds of the box. We're going to make a getBounds method which takes the reference of the top left bound and the bottom right bound to return. First, let's get the height and width of the sprite. Then the top left bound is simply the position minus half the width and height, and the bottom right bound is the position plus half the width and height. However, this is not finished. What if the sprite rotates? It has a different height and width. With this code, the bounds would be inaccurate. Now I've done these calculations for you using sine and cosine. This works because if the angle is 0, the sine becomes 0. If the angle is 90 degrees, the cosine becomes 0, and now the height and width are switched. After getting the bounds, it's time to compare them. So let's put all the conditions in. The top line checks if the x coordinates are overlapping, and the bottom line checks if the y coordinates are overlapping. Finally, we should only check this if both entities are alive. That's all done, let's see if they all work. I made the sprites turn red if they overlap. Thanks for watching, and smash that subscribe button if you feel so inclined.